It's one of the most intriguing locations in the world. Covered in darkness and miles underwater, this extreme environment is home to some unusual creatures and phenomena. It's called the Mariana Trench, and it's the deepest oceanic trench on Earth. No wonder it's been so difficult to explore. Because of the risky conditions, people aren't able to explore this location without proper equipment. But what would happen if we threw a steel ball down there? Let's start with some basics. How did they first discover this enormously deep hole in the ocean? HMS Challenger identified it back in 1875. The ship had some pretty fancy sounding equipment for its time, but it wasn't nearly good enough to be able to fully explore the trench. Some decades later, in 1951, another ship, the HMS Challenger II, came back to the location better equipped. The vessel featured an echo sounder and was able to take accurate measurements of what seemed to be the deepest point on the surface of our planet. If you were to look at it in 2D, you'd see the trench measures 1,500 miles in length and 43 miles in width on average. It also looks sort of like a crescent-shaped scar when you observe it from above. Nothing out of the ordinary so far, right? Well, if you were to stretch a wire from the surface of the ocean to the trench's deepest point, it would measure a staggering 7 miles. If we were able to physically move Mount Everest, which is the Earth's tallest mountain, to cover the Mariana Trench, it still wouldn't be enough, falling short by about a mile. Because the Mariana Trench is so deep, it's almost completely covered in darkness, as light can barely get through to such extreme distances underwater. The temperature isn't any friendlier either, just a few degrees above freezing. But the most dangerous feature of them all is the water pressure. Right at the deepest point of the trench, the amount of pressure is about 1,000 times higher than the standard atmospheric pressure. Not a lot of people ever attempted to descend into the Mariana Trench. In fact, the first organized attempt took place more than 60 years ago. It was done by Jacques Piccard and Don Walsh in a submersible. They only spent about 5 hours on their descent and a mere 20 minutes at the bottom. Alas, they weren't able to take any pictures. Until these two scientists were able to descend, specialists believed there was little to no chance that life could exist down there, given the conditions, most notably the extreme pressure. But while at the bottom, the submersible's floodlight caught sight of a creature. It was a very flat one indeed. As you can imagine, resources here are very scarce. What kind of creatures live down here? And how do they survive, given the harsh environment? Surprisingly, there is quite an abundance of wildlife living in the Mariana Trench. Some of these creatures fall back on chemicals to survive, like methane or sulfur, while other kinds of fish nibble at the marine life that's, well, weaker than them on the food chain. The most common creatures found here are xenophyophores, amphipods, and small sea cucumbers. Some of them adapted by hardening up their shell using aluminum harnessed from the seawater. Smaller creatures, like microbes, adapted by feeding on the chemicals emitted when the seawater hits the underwater rocks. They consider the Mariana snailfish the rock star of the area in terms of wildlife. They're small, ranging from 3 to 9 inches, translucent, and lacking any scales. But they're the top beast of prey in the area. It's no wonder some people started to believe that the ancient megalodon might still be living here. What was a megalodon, you might be wondering? It was the largest predator ever known in our planet's history. Basically, the biggest and nastiest shark ever to have lived. Scientists believe it's been extinct for quite some time, and the idea that it might still be hiding in the Mariana Trench doesn't have a lot of supporting information. The megalodon would have needed to learn to navigate in complete darkness. It would either have to be bioluminescent or evolve to have massive eyes. More so, because of its school bus-like size, the megalodon would have needed a lot to eat. Microbes and small snailfish just wouldn't have done the trick. If a steel ball were to be dropped in the trench, what would be its effect on it? Would the ball be strong enough to sustain such pressure? Let's look at the science here. If we assume it's a solid steel ball, the pressure found at the bottom of the trench wouldn't be enough to really affect it and cause permanent damage. It would take it a solid 12 minutes to reach the bottom of the ocean, though. What about the temperature? Well, It turns out that the difference in temperature on the surface and at the bottom of the trench is quite impressive, a difference of about 86 degrees Fahrenheit. So, it would cause the ball to shrink a bit, but yet again, once the ball returns to the surface, it would simply come back to normal. Should the ball get stuck there, there's another interesting question to answer. Would corrosion affect it? Corrosion of steel is highly dependent on the amount of oxygen in the water. The amount of oxygen dissolved in water remains constant at depths greater than 3 miles. I'll spare you the math, but it would take more than 10,000 years for the steel ball to completely rust under the sea. I can't help but wonder, though, what would it take us humans to be able to survive at such extreme depths? Let's look at what was used in the past to explore this mysterious location. A little thing called syntactic foam. Why? Because it's the only material that can both float and resist the amount of pressure found here. Without this sort of protection, our lungs would rapidly collapse here. More so, the pressure from the water would push liquid into our mouths, replacing the much-needed oxygen with water. Then, there would be the much-needed ability to be able to come back to the surface should anything not go as planned. One of the vessels that went for a deep dive here had 1,000-pound steel weights attached to it, so it would ensure its sinkage. These weights were connected to the ship by a special type of wire that had an increased corroding time of 11 to 13 hours in seawater, just in case something went wrong down there, and they'd have to bounce back faster. Given the harsh conditions here, the problem of oxygen supply is really important too. Any vessel looking to descend into the Mariana Trench again would need to consider some sort of device that can recycle the air in order to reduce the amount of oxygen that needs to be transported down there. And the last, but definitely not the least of all problems, would be electricity. There surely isn't a power socket down there for you to charge your phone. So, there needs to be enough battery life to support all the necessary equipment, communication, oxygen supply, lighting devices, and so on. None of these problems seem to be quite the challenge anymore, since, as of recently, you can buy a tour of the Mariana Trench. 3 lucky individuals were part of such a project back in 2020. They were submerged in a 3.5-inch thick titanium sphere. This ensured that they didn't feel any pressure changes and physiological stresses whatsoever. Each of the guests took part in an individual trip that had an estimated length of about 14 hours. The descent itself took over 4 hours. Once they reached the bottom, they got the chance to witness some of the most extraordinary creatures on the planet. Then it was time to start the 4-hour ascent back to the surface.
Can you swim? Good. Because you're going on a journey to the deepest point of the Pacific Ocean. Now, put on your flippers. The very bottom of the Mariana Trench is awaiting. Now, get in the water. Really, come on. All right. 1 foot underwater. That's the depth you can swim with no special gear like a mask. Hey, look, must be some tourists. Or whales. 10 feet underwater. That's a little deeper than the public pools and beaches around the United States. You can see colorful fish and even phytoplankton that feed on the sun's rays. 26 feet down. This is the depth at which the foundations of the floating city of Venice in Italy stand. Builders laid columns at that depth on which they later built houses and streets. 30 feet underwater. You start to feel a lot of pressure. When you're on the surface, you're under atmospheric pressure, 15 pounds per square inch. But here, at 30 feet, that pressure is doubled. All the air pockets in your body, like your lungs or ears, begin to compress from this pressure, giving you discomfort. But no worries, your organs are soft and elastic, so you can keep diving. 40 feet underwater. Oops, you're running out of air. An average person can hold their breath for 30 to 90 seconds. The current record is an incredible 24 minutes and 37 seconds. Gasp. Okay, you'll need some diving equipment to continue your descent. There you go. Thank you very much. Tourists dive to this depth to look at reefs and corals. You don't need special skills for that, but you can't dive any deeper without training or a license. 45 feet down. Be careful. There's sharks swimming here looking for food, like you. Sometimes tourists descend to this depth in a safe cage to see the sharks up close. You're better off staying away from these predators and not attracting their attention. So make sure you're not wearing any bright and shiny jewelry. Sharks love that kind of thing. 62 feet underwater. You could see the Aquarius Reef Base Lab in Florida at this depth, if you were in Florida. It's really an entire building with rooms for exploring the seafloor, accessible through a hatch. 105 feet down. You see a strange bell hanging from a chain. People used to use these things for deep diving about 400 years ago. They'd lower a bell on chains with divers inside from a ship. There was enough air inside the bell for them to breathe. That way, they could explore sunken ships with treasures. 140 feet. At this depth, you could find an entire sunken city in Qianda Lake, China. You can still see streets, houses, and temples there. 330 feet. Whoa! You almost hit a huge blue whale. How could you miss it? These guys, the size of 2 train cars, usually dive to that depth. Shh! Let's listen to them sing for a while. It's beautiful. Now, let's keep going. 660 feet. This is where most of the ocean life ends. Sun rays hardly penetrate any deeper into the water. Everything below are unusual fish like this angler. They have such an unusual appearance because they have to adapt to the high pressure here. 702 feet underwater. This is the last mark where you'd see a human without diving equipment. This man holds the title of the deepest man on Earth, and he's the only one who has managed to get to this depth. The water pressure on his body here was 20 times greater than that on the surface. 985 feet. Ooh, what was that sound? Whoa, that's a submarine. That's the maximum depth they can dive to. Some of them can reach speeds of 26 miles per hour. Fun fact, an ostrich can run twice as fast, but she can't swim. 1,090 feet. Say bye to this scuba diver. You won't see them any deeper than this. The world record was set in the Red Sea. It only took the diver 12 minutes to reach this depth, but it took him a whole 15 hours to return to the surface to avoid decompression sickness. So now you get an atmospheric deep diving suit. It's completely sealed, and you won't feel the insane water pressure on your body in it. 1,454 feet. If you stuck the Empire State Building in the water, its tip would be here, and all the carpet inside of it would be wet. 2,300 feet down. The water pressure here is 70 times greater than on the surface. The flexible plastic parts of your suit can't withstand that kind of pressure. So here's some urgent delivery. It's an ultra-deep submersible. Now you can continue your dive all the way down. 2,717 feet. Here you'd see the tip of the tallest building on Earth, the Burj Khalifa. Alright, who's sinking all the tall buildings around here? 5,387 feet. This is the depth of one of the oldest and deepest lakes in the world, Lake Baikal. Its area is slightly larger than the entire country of Belgium. 8,040 feet. That's the record depth the Perdido oil platform reaches in the Gulf of Mexico, and its above-water part with 3 decks is almost as high as the Eiffel Tower. 11,962 feet. This is the average depth of the Atlantic Ocean. You can see a huge tube as wide as a giraffe's neck, and it just seems to be endless. True, this cable connected Europe and North America and used to serve for telegraph communications. 12,303 feet underwater. Suddenly, in the darkness, you see the outline of a ship. No way! That's the Titanic itself. The intense water pressure would crush a person at this depth, so you can only dive down to the Titanic in a submarine. 13,123 feet. Whoa! Here would be the end of the deepest mine in the world, Imponen Gold Mine in Africa. But you still have deeper places to go. Let's speed up. 20,000 feet. Here you can see the deepest debris of an old ship. The USS Johnson sank more than 70 years ago. You can still clearly see the number 557 on its bow. 26,200 feet. Here, in this total darkness, you'll find the deepest fish in the world, the Mariana snailfish. They're as long as a domestic kitten and have almost transparent skin. Their eyes are poorly developed for vision because the sunlight never reaches this deep. 29,030 feet. If you take Mount Everest, flip it over, and stick it into the Mariana Trench, this is exactly where you'd see its tip. Even though this is the highest point on our planet, you'd still have a lot deeper to go. 35,755 feet down. Here, in the Challenger Deep, you'd still see life. You'd need a microscope for that, though. Bacteria living here feed on organic molecules, similar to oil. A little deeper? Congrats! You've touched the bottom. It's 36,070 feet deep. The pressure here is 1,071 times higher than on the surface. But you're not the first person to have been here. One of the last expeditions to the bottom of the Mariana Trench was in 2012. An American filmmaker descended here in a submarine he designed himself. But the pressure broke some of the engines, so it was hard for him to maneuver here. The sonar was also damaged, and some of the batteries drained. He was in the Challenger Deep for about 3 hours and took many pictures and videos. If you look closely at the bottom itself, you can see bubbles. It's carbon dioxide and liquid sulfur. It's freezing here because of the extreme pressure and temperature close to freezing. But there's still life here in these harsh conditions. The 3 microorganisms are most common here: xenophytophores, amphipods, and small sea cucumbers. There's so few of them because they don't have enough food down here. Usually, there's a lot of palm leaves on the ocean floor, which get there from the land. But the Mariana Trench is 124 miles from the nearest islands. So the only food here is old plankton and fish scales from the ocean's upper layers. But it needs to travel tens of thousands of feet to become food for the bottom dwellers. But can you go even lower into the crust of the Earth? Well then, you'll need to unleash your giant drill and fire up the jet engines. You're pushing another 36 miles through the Earth's crust, and here is its edge. You've entered the upper mantle. It's an ocean of hot lava, 1,800 miles deep. You have to literally swim through this, reaching the outer core, another 1,400 miles deep. Then you reach the inner core, another 755 miles, and congrats! You're at the very center of the Earth. I hate to ask, but how do we get out of here?
Wanna high-five a sea creature? Well, put your hand up for the Tasmanian red handfish. This fish doesn't swim like a fish. It walks. It uses its flipper-like hands to stroll around on the ocean floor. These bottom walkers are disturbed by swimmers and boats a lot. Some people even want to take them home as pets. I think it's better to just give them a wave and swim on by. The vampire squid. Its species name is Vampiroteuthis infernalis, which translates to vampire squid from hell. Oh yes, this vampire squid means to terrify everyone with its name, its dark red color, its spikes at the bottom, and the scary fact that it can basically turn itself inside out. The vampire squid loves putting on a good show, but it's as harmless as a kitten is to humans. It's as if Dracula scared the pants off you, but he didn't have blood-sucking fangs. The vampire squid feeds on food particles from plants and animal matter floating near the ocean's surface. Since they're not predators, they need good defensive strategies, and their vampiric look is designed to ward off large creatures who want to eat them. Turning themselves inside out is a defensive mechanism since the spiky areas in the inner skin are more intimidating. They also shoot out a substance that does not have color, but is packed with bioluminescent particles to distract predators. The vaquita. Going out on a boat off the coast of Mexico sounds like the perfect vacation. The sun, the blue water, the most endangered sea creature. Wait, what? The vaquita isn't dangerous, but don't expect it to stick around to say hello or sign any autographs. It's incredibly shy. This little cow, that's what it means in Spanish, is one tiny sea mammal. With those black markings around its eyes, it looks more like a sea panda to me. Seeing one should make you feel very special. They're on the brink of extinction, mostly because they got caught by accident in fishing nets. It's estimated that there's only 10 left in the wild. The blue dragon. This little creature looks like something out of a kid's fantasy movie. It's called the blue glaucus, casually referred to as the blue dragon or blue angel. It can be found in many places, the Atlantic, Pacific, and Indian Oceans. It's kind of a mollusk and it only grows to be about an inch long. What you think is the back is actually the mollusk's bright underbelly. It regularly floats on its back so that its blue colors help it camouflage with the water's waves. The blue dragon isn't just pretty, it's also smart. It usually feasts on Portuguese man-o'-wars, also known as Physalia physalis. The blue dragon stores their stinging cells for later use, in essence, stealing their defensive mechanisms. When the blue dragon is threatened, it releases those stinging cells it stored, directing them at an enemy to sting them with more power than the Portuguese man-o'-war would have been capable of. As they can store a huge amount of stinging cells, they can be a threat to humans. So, if you find one, don't pick it up. It's best to admire it from a distance. The barrel-eye fish. If you ever wanted to have Superman's X-ray vision, looking at the barrel-eye fish will make you feel like you gained that superpower at some point in your life without even realizing it. The barrel eye has a transparent head, so you can see how their eyes and brain look inside. This magnificent creature lives in the deep sea. This is the lowest level of the ocean, where strange creatures roam in near-freezing temperatures and constant darkness. They're exposed to water's pressure that's almost 1,000 times that of the surface. If the idea of the deep sea sends a shiver down your spine, stay tuned to learn about another of its creatures later on. The barrel-eye fish can be found in the Atlantic, Pacific, and Indian Oceans. You might be wondering, why oh why would a fish have a see-through head? And that would be a fair question. Since the species was discovered in 1939, it was believed that the fish's eyes were set to see straight ahead and couldn't move. So it was assumed that they had tunnel vision. Scientists Bruce Robinson and Kim Reisenbichler from the Monterey Bay Aquarium Research Institute recently discovered that the fish can move its eyes vertically to see through the top of its translucent head, thus noticing if there are predators or prey nearby. The transparent head also allows more light to enter so they can detect prey better. It's believed that the barrel-eye fish eats jellyfish and small fish species. If you dive in the ocean at night, you might be lucky enough to see how orange ball corallomorph blooms in the dark. But make sure to be quick because as soon as you turn on your flashlight to take a good look, it will retract its tubes back into itself. The megalodon. The whale shark isn't the biggest shark known to humans. If the entire shark species were a kingdom, the prehistoric megalodon would be the ruler of the sea. Megalodon roamed the ocean a long time ago. About 15.9 to 2.6 million years back between the early Miocene and late Pliocene eras. While they've long been extinct, people are still amazed to learn about these gigantic sea beasts. Megalodon could reach anywhere between 45 feet to 60 feet in length with jaws more than 6 feet wide. A fossil of a tooth that once belonged to a megalodon measured at 7 inches. Needless to say, I'm pretty stoked that these guys have long been extinct. But there's still some adventurers out there hoping to meet this monster one day. The Dumbo octopus. This adorable creature, or creepy creature, or however you want to see it, is officially called Grimpotieuthis. More casually, it's referred to as the Dumbo octopus, named after the Disney character. Though Dumbo, the elephant, not the octopus, was teased for his big ears, it's highly unlikely that this adorable octopus gets teased by its water neighbors. They are the deepest living octopuses, living in the deep sea, and you know how scary that place is. They're only about 8 inches tall and spend their days hovering just above the seafloor eating snails, worms, and other food they find in the current or near ocean vents. There are nearly 17 species of Dumbo octopus, and they all have differences in height, color, and body parts. If you can't get enough strange animals, you'll be glad to learn that the deep sea has barely been explored by humans. So keep an eye out. There are bound to be more fascinating animals discovered in the deep in the future. The sea angel. These creatures might look and sound pretty cute, but their diet is far from sunshine and lollipops. Their favorite food are sea butterflies. They lay mucus traps for them and wait in ambush. The squat anemone shrimp. This shrimp is tiny, only 0.5 inches. It's also known as a dancer shrimp because of its peculiar behavior. When agitated, it raises its bottom above its head and does a little dance. Divers also say it readily jumps on their hands and cleans them. The coconut crab. This guy may look pretty creepy, especially when the sun goes down. Mature coconut crabs are around 3 feet in length. Their preferred foods are coconuts, but they can also hunt down lizards and even large birds. The slender snipe eel. Slender snipe eel is a slim and long creature that's still a mystery for marine scientists. It's 4 feet long and it has at least 750 bones in its spine, which is much more than any other animal in the world. The sea pen. Sea pen is 7 feet long and it has a lot of varieties, but most of them look indeed like a pen or a quill. The similarity is even more striking when the animal has a water-filled bulb that anchors it to the floor. The Persian carpet flatworm. This creature looks indeed like a carpet, despite being very small by comparison. It's only 4 inches long, able to become both male and female. It doesn't really mate with other flatworms. Rather, it fights them for the right to bear posterity. The flamingo-tongued sea snails. Tourists love these extraordinary snails for their pretty colors, thinking it's a shell, but in fact, the shell is quite dull and hidden underneath colorful soft tissues. They eat softer, toxic parts of corals and store their toxins to protect themselves.
Hello, Brightsiders! Do you know where the deepest place in the world is? I think it's in the Pacific Ocean, near the Philippines and Papua New Guinea. It's the famous Mariana Trench. So let's take a tape measure, a very long one, and attach its end to the boat on the surface. Now we hold our breath and jump in the water. Fish and marine animals swim by. We descend lower to the depths and into total darkness. And after several hours, we reach Challenger Deep. The tape measure shows a depth of 36,200 feet. The famous Mariana Trench is not the deepest place on Earth, as everybody thought. The Kola Superdeep borehole, located in Murmansk region in Russia, beats it by a wide margin. And scientists have discovered something unusual and sinister there. When geologists were drilling the hole, they could reach the depth of 9 miles. And then they encountered voids. Scientists on the surface were surprised and scratched their heads and then decided to lower a microphone and dozens of other sensors in these voids. The temperature down below turned out to be 2,000 degrees Fahrenheit, and the microphone recorded something that sounded like human groans and screams. Many people thought the scientists had been able to drill into the underworld. The shocked people up above had already begun to panic, but suddenly an unknown creature jumped out of the drill pipe. It looked like a black goat that walked on its hind legs. Its body was shrouded in black flames. The creature got out of those deep hollows and ran off into an unknown direction. Okay, wait. These are just myths that one newspaper published on the 1st of April. It's International Joke Day, by the way, but many people believed it. It made many believe the scientists working at the borehole had opened a portal to the nether, and that now horrible, outworldly creatures were free from their imprisonment. But like with any myth, there's some truth to it. The deeper the scientists drilled, the higher the temperature got. At 3 miles deep, it was 160 degrees. At 4.5 miles, it was 250. And at the maximum depth of 7.5 miles, the sensors recorded a temperature of 413 degrees. One day, scientists heard a loud explosion underground. They stopped working and everyone tried to find out what caused such a loud pop. But there was seemingly nothing there. After a while, they continued drilling deeper, and at the same depth, no accidents happened. The drilling began in May 1970. They passed the first 4.5 miles quite easily, and it was primarily hard granite rock. It was like drilling through a hard wall. But then their drill went into softer layers, and the shaft of the hole began to crumble. It was like drilling in wet sand. Every time that workers took the drill out, there was a risk that the hole would collapse under its own weight. As that eventually happened, the scientists picked a new direction to drill, and you know what's interesting? In the end, the map of the entire well looked not like a straight beam from top to bottom, but like a tree trunk which had diverged into many different routes. 9 years later, scientists reached the depth of 31,400 feet and broke the world record for the deepest borehole. By 1983, they made it another 8,000 feet deeper. After a brief pause in the work, there was an accident. A part of the drill broke away from the main body and remained in the borehole. For several months, scientists tried to extract the drill, but nothing worked, and they had to return to the depth of 4.5 miles and start all over again. The drill was divided into sections, and one such unit could only last about 4 hours before it had to be replaced. In terms of depth, that was only about 32 feet of drilling. Then the drill was lifted to the surface, replaced, and lowered back down. On average, the drilling speed was about 200 feet per month. That's like a 20-story building. In 1990, 20 years after the work had begun, scientists reached the final depth of 40,230 feet. That's like 100 soccer fields down. And after another accident, the work stopped. Guinness World Records registered the Kola Superdeep Borehole as the deepest borehole in the world. It's like Mount Everest plus 9 Empire State Buildings on top of it. One of the most unusual discoveries at the Kola Superdeep Borehole was that the soil at the depth of about 2 miles almost perfectly matches the composition of the surface of the moon. It has given us more insight into how our ancient satellite appeared and formed. It seems that in the early stages of Earth's formation, a giant asteroid crashed into our planet. With that kind of force, it caused an explosion so powerful that part of our planet broke off and flew upward. This chunk of Earth remained in our planet's orbit, cooled, and later formed into the moon we know today. Another surprise for the workers was the presence of gold. There was about 2.5 ounces of gold for every ton of soil lifted. The deeper the scientists went, the older the rocks were. In layers of rock about 2.8 billion years old, they found fossilized remains of living organisms. It made the world of science bubble with excitement, as it meant that life on our planet appeared 1.5 billion years earlier than first thought. In the early 1990s, they shut down the drilling project. Gradually, the buildings around the borehole and the drilling equipment were lost. Today, a lot of tourists visit the place. It's because of those same myths about creatures from the underworld. Yes, there's a hole 7.5 miles deep under that rusty lid. But the scientists working there never reached their goal. They wanted to drill into the Earth's mantle, but to do that, they would have had to dig down to a depth of about 44 miles. At 200 feet per month, it would have taken as long as 80 years. That's assuming no accidents happened. But the deeper it goes, the more interesting it gets. A few years ago, they found a massive amount of water deep underground. Somewhere up to 370 miles down, there's a substantial ocean billions of years old, and the amount of water there is several times greater than in all the oceans, seas, and rivers combined on the surface of Earth. The water there is at a scorching 2,800 degrees Fahrenheit. But because it's under a tremendous pressure, it doesn't evaporate. It's encased in a crystalline structure of minerals. This ocean was formed in the early stages of our planet's development, when there was only hot lava and debris of space bodies around. But the most exciting thing you can find by drilling is living organisms. They've been there in isolation for billions of years, and they can give us clues as to how life came into being in the first place. Scientists in Antarctica have created a similar borehole. An entire lake half the size of Lake Ontario was discovered under the thick ice. The amount of water in this lake is only 3.5 times less than in the Lake Baikal, the largest lake on Earth by volume. The ice that hides this lake is at least 20,000 years old, and the water beneath it has been isolated from the outside world for about 15 million years. While drilling, scientists lifted a chunk of ice from deep down below and found an unknown bacterium on it. Its genetic code was only 86% similar to known living organisms. That means that we've never seen bacteria like this before, or it had come from outer space. But that's just a theory. We know that these bacteria can live in unusual conditions and at water temperatures below freezing. The composition of underground lake water is also different from what we're used to. There's a lot more oxygen and carbon dioxide in it. Add to these conditions complete isolation, and we get living organisms that have developed and evolved in a completely different way. Do you understand what it means? The study of deep organisms may give us a clue as to whether life could exist beneath the ice on other planets or their moons. For example, Saturn's moon, Enceladus, has ice 24 miles thick. There may be an ocean underneath, which is heated by thermal springs. That's all for today. And guys, remember, let's become smarter every day together with Brightside.
Most of the ocean is still shrouded in mystery, whether we're talking about dark corners or creatures that are hiding in the depths. But sometimes it gives us a peek into scary things it hides in its cold, dark depths. Like when you hear on the news that there are some deep sea creatures washed ashore after a powerful storm once again. Some just look weird, while others are real monsters that live at depths of more than 3,300 feet. The coldest and deepest parts of the ocean have created one specific phenomenon called gigantism. So, sea spiders, squids, worms, and many other animals, mostly invertebrates, or creatures without backbones, they're all way bigger and scarier than the versions we see in the more shallow areas. In the Pacific depths, you can see a sea sponge as large as a minivan. Or what about the colossal squid that lives in subantarctic waters and is nearly 14 times longer than the arrow squid, a type that mostly lives in New Zealand? Researchers found many of these underwater monsters in the abyssal zone of the ocean. Back in 2021, the researchers showed images of the giant phantom jelly. It was at a depth of 3,200 feet. Its tentacles were 33 feet long. Wow, I wouldn't like to face that one on the beach. It probably eats only small fish and plankton, but it can swim to depths of more than 21,900 feet. And down there, this giant jelly doesn't have enough food. How does it survive then? Scientists haven't figured it out yet. And there are even more questions related to the giant squid, the biggest one ever found. This monster is 43 feet long, with a weight of nearly a ton. Imagine if those tentacles would grab your car, or something like that. They would smash it like it was a toy. There's no light in the abyssal zone. Sun rays just can't penetrate that deep. So there's no algae or underwater plants there. Local animals mostly eat snow. Marine snow is not like the regular one you build a snowman with. It consists of any small flakes or remains that fall from the surface of the ocean. Maybe even some leftovers that animals up there couldn't eat. So it's not much. But apparently, it's enough for very large creatures that hide deep down there, like giant squids. Squids that generally live at such depths don't bother going after their prey. They just wait until the poor animal swims right up to their long tentacles and falls into a trap. It may not be the best method ever, because not many animals will even swim into these dark, cold parts. but it's the method that saves energy. A giant squid eats only 1 ounce of fish daily, which is approximately 45 calories. That's nearly 50 times fewer calories than an average person should eat per day. So when a squid gets 1 fish, it saves it for a couple of days. I hope giant squids won't get the idea to go to the surface and look for food when there's not enough of it in the abyssal zone. And I hope even more that giant Greenland sharks won't get that same idea. You can find them at depths of up to 7,200 feet. They're twice as slow as we usually walk. They swim at a speed of 1.12 feet per second. Their slowness is part of the energy-saving mechanism that creatures down there need to survive. But they can speed up in the form of short bursts when they need to catch prey. But they kinda change their diet from predator to scavenger, considering their environment. There will be more leftovers falling from the surface than animals to go after. Greenland sharks grow just 0.4 inches per year, and they're mostly 20 feet long, which means they live for a very long time, sometimes up to 400 years. They also have a slow metabolism, and that's one of the main factors for their long life, too. Greenland sharks like to spend their time in cold waters. They're adapted to that, since their tissues have specific chemical compounds that prevent the forming of ice crystals all over their body. That means they have some sort of natural antifreeze. So what makes them so big? Scientists are still not sure, but some theories try to explain it. There's this thing called Kleiber's rule that says bigger animals tend to be more efficient. Just take a small fish and compare it to a whale with a mass hundreds of times bigger. The whale has a greater metabolism. It conserves energy more efficiently and loses less of it to the surroundings through heat. Moving on, bigger animals can ingest bigger prey. They're more likely to go through tough issues in their environment or defend themselves from predators going after them. Also, the body gets bigger when temperatures are lower. The Greenland shark is a perfect example. So are giant sea spiders. Sea spiders are generally common, and you find some very small ones at 0.04 inches. But in deeper parts of the Antarctic, they become 3-foot-long giants. They grow so big because the cold water has more oxygen. That way, more of it diffuses into the animal's body, and that allows it to grow bigger. Yeah, both as a creature and a nightmare. And how about this giant tube worm? Researchers found it accidentally while they were exploring the mysteries of the Pacific Ocean floor. They stumbled upon unusual hydrothermal vents. Volcanic heat is a thing that gets them going. As water seeps down through faults or cracks in the rock, these vents change their direction. When the water gets out of the vent, it's rich in different minerals and chemicals. Most animals wouldn't survive being around this toxic soup of chemicals, but not these tube worms. They came as a true surprise, because not only are they not bothered by these toxic vents and the almost boiling temperature of the water, but they developed entire ecosystems there. They're unique because they don't need sunlight to survive. Instead, small bacteria are their main source of energy. That bacteria gets their energy directly from these toxic chemicals. So it's not photosynthesis, but a process called chemosynthesis. And these tube worms don't have mouths. These bacteria live inside them. Strange story, huh? Plus, these scary worms reach up to 8 feet. Giant isopods are no better either. They lurk at the depths of the ocean of 1,640 feet or more below, far away from the sunlight, looking like some monstrous wood lice. They spend most of their time on the seabed, hoping to find some food falling from higher levels of the ocean. Check out their small hooked claws at the ends of their legs. Isopods use them to remain more stable while moving around the ocean floor. Since there's no light, they have long antennae that help them feel their way around. These sensory antennas are about half the length of their body. Giant isopods have pretty big eyes compared to their body size, too. They can grow over 12 inches from head to tail. And these fellas are really patient. Remember how we said animals down there rarely get food? Sometimes they need to wait for years to get a proper meal. That's why their metabolism is amazingly slow.
5 years later.
They can go for 5 years without eating anything. Imagine that. I get hungry just talking about this. In 2006, a biologist did research to compare the differences between the shallows and the deep sea regions. He realized the deep sea mirrors the island rule. First, isolated parts of land develop biodiversity you won't find anywhere else. Second, small-bodied life there grows much bigger when it's isolated, compared to life on large land masses. Resources are limited, but also competition and predators. And we don't know much about these deep-sea creatures. It's too expensive and too complicated to carry out such research, so we'll just wait for more raging storms to show us at least part of the monstrous world cold ocean depths hide.
Welcome, dear listeners, to another episode of our exploration series. Today, we're diving deep into a world that is closer to us than the moon, yet remains largely unexplored. A world that covers over 70% of our planet's surface, yet we've only scratched the surface of its mysteries. Yes, you guessed it right. We're talking about the vast, the deep, the beautiful, and the mysterious, our oceans. Despite our technological advancements, we've explored just a mere 5% of these underwater worlds. To put that into perspective, more people have set foot on the moon than have ventured into the deepest part of our oceans, the Mariana Trench. So, buckle up as we embark on this fascinating journey, exploring the depths of our oceans, the creatures that inhabit it, the unique phenomena that occur beneath the waves, and the challenges we face in uncovering these underwater secrets. Stay tuned as we dive deeper than ever before into the mysteries of our blue planet. Let's make pause for a moment and consider the immense pressure and depth that we're dealing with. It's easy to forget when we're standing on the shore, watching the waves gently lap against the sand, that beneath the tranquil surface of the sea lies a world that is as alien to us as the surface of another planet. Imagine, if you will, descending into the ocean. As you go deeper, the light from the sun fades, replaced by an all-encompassing darkness. The weight of the water above you increases, and with it the pressure. This is a world where the pressure isn't just a metaphorical weight on your shoulders, but a literal one. At greater depths, the pressure is so intense that it's harder to send people to the bottom of the ocean than to send them into space. Yes, you heard it right. Space, the final frontier for many, is easier to reach than the depths of our own oceans. In space, as we ascend through the Earth's atmosphere, the pressure drops to zero. But in the ocean, it's a different story. The deeper you go, the greater the pressure, reaching levels 1,000 times greater than on land. It's like having hundreds of elephants standing on your head. It's a world where human beings, as we are, cannot survive. Yet despite these extreme conditions, life thrives. Creatures of the deep have adapted to survive in this high-pressure environment, leading to a biodiversity that is as stunning as it is surprising. But for us, to explore these depths, we need to overcome these challenges. We need to build machines capable of withstanding these pressures, and we need to find ways to protect ourselves from the crushing weight of the water above us. As we delve deeper into our exploration, we encounter a fascinating phenomenon: the shifting of oceans and continents. The Earth as we know it has not always looked the same. Over millions of years, the continents have drifted apart and come together in a slow dance orchestrated by the movements of the Earth's crust. The Atlantic Ocean, for instance, is a testament to this incredible geological process. It was formed when the North and South American continents separated, creating a vast body of water in between. And even now, it continues to grow, expanding at a rate of about 2 inches per year. On the other hand, the Pacific Ocean, the largest and deepest of Earth's oceanic divisions, is slowly shrinking. This constant, albeit slow shift in our planet's geography is a reminder of the dynamic nature of Earth. These movements not only shape the physical landscape of our planet, but also influence the distribution and evolution of species in our oceans. The shifting continents have created diverse habitats, leading to the evolution of a myriad of marine species, each adapted to their unique environment. The ocean is a treasure trove of natural wonders, many of which are as astounding as they are unexpected. Beneath the surface, there are features that rival, if not surpass, the grandeur of those we see on land. Consider, for instance, the existence of underwater lakes and rivers. Yes, you heard it right, lakes and rivers within the ocean itself. This seemingly paradoxical phenomenon is possible due to a combination of salt water and hydrogen sulfide, which is denser than the surrounding water. This denser mixture forms lakes and rivers that flow right inside the ocean, creating an otherworldly spectacle for those fortunate enough to witness it. And then, there's the world's biggest waterfall, not on land but underwater. Known as the Denmark Strait Cataract, it's located in the waters between Iceland and Greenland. Standing at an impressive 11,500 feet tall, it dwarfs the likes of Niagara Falls. This underwater waterfall is possible because cold water is denser than hot water, causing it to drop into the much warmer Erminger Sea. But the wonders don't stop there. The longest mountain chain on Earth, the Mid-Ocean Ridge, is also hidden beneath the ocean's surface. Stretching almost 40,000 miles long, it's a testament to the Earth's dynamic nature. Yet, despite its size, we've studied only about 1% of this underwater mountain range. We know less about this chain than we know about the surface of Mars or Venus. These features, hidden beneath the waves, remind us of the ocean's complexity and grandeur. They challenge our understanding of the natural world and invite us to explore further, to uncover more of the ocean's secrets. As we journey deeper into the ocean, we encounter the true stars of this underwater world, the marine life. The ocean is teeming with a diversity of life forms that is as breathtaking as it is varied. From the smallest plankton to the largest whale, each creature plays a vital role in the complex web of life that exists beneath the waves. Consider the corals, not just a single organism, but a bustling community of life. These underwater cities provide shelter, food, and breeding grounds for a multitude of marine species. They are the rainforests of the sea, teeming with biodiversity. Then there are the algae, the unsung heroes of our planet. These microscopic organisms produce about half of the world's oxygen through photosynthesis, a process that also absorbs carbon dioxide, helping to mitigate climate change. The ocean is also home to some of the most fascinating creatures on Earth. Take the octopus, for example. This intelligent invertebrate has 3 hearts, 9 brains, and can change both its color and texture in a split second to blend in with its surroundings. Or the Antarctic fish, which have developed natural antifreeze proteins to survive in the icy waters of the Southern Ocean. These proteins prevent ice crystals from forming in their blood, allowing them to thrive in conditions that would be lethal to most other fish. And let's not forget the sharks, the apex predators of the ocean. With their streamlined bodies and highly developed senses, they are perfectly adapted for a life of hunting in the ocean. These are just a few examples of the incredible diversity of marine life in our oceans. Each species, each individual, is a testament to the power of evolution and the adaptability of life. The more we learn about these creatures, the more we realize how much more there is to discover. As we venture further into the depths of the ocean, we encounter creatures that seem to belong more to the realm of science fiction than the natural world. These deep-sea dwellers have adapted to survive in an environment that is among the most inhospitable on Earth. Take, for instance, the goblin shark. With its long, flattened snout and protruding jaws filled with nail-like teeth, it's a creature that seems to have been plucked straight out of a nightmare. Yet, it's perfectly adapted to its deep-sea environment, using its unique jaws to snatch up prey in the dark depths. Then there's the fangtooth, a fish that, true to its name, boasts some of the largest teeth of any fish in the ocean, relative to its body size. Despite its fearsome appearance, the fangtooth is quite small and harmless to humans. The frilled shark, another deep-sea dweller, is often referred to as a living fossil because its primitive features have changed little over millions of years. With its serpentine body and fringed gills, it's a striking reminder of the diversity of life in the deep sea. And let's not forget the Mariana snailfish, a species that calls the deepest part of the Mariana Trench home. Living at a depth of 24,000 feet, it's the deepest living fish ever discovered. In this extreme environment where the pressure is 1,000 times greater than at sea level, the snailfish thrives, demonstrating the incredible adaptability of life. These deep-sea creatures, with their alien-like appearances and incredible adaptations, challenge our understanding of what life can endure. They remind us that even in the harshest conditions, life finds a way to thrive. As we continue our exploration, we encounter a surprising fact about our oceans. They are, quite literally, a gold mine. It's estimated that there are about 20 million tons of gold dispersed throughout the oceans. However, before you start planning your underwater treasure hunt, there's a catch. The gold in the ocean isn't clustered together in easy-to-find nuggets or veins. Instead, it's spread throughout the ocean's waters, at a concentration of about 13 billionths of a gram per liter of seawater. To put that in perspective, you would need to process over 50 million liters of seawater to collect a single gram of gold. That's about 20 Olympic-sized swimming pools for a piece of gold that would barely cover your fingertip. Even on the seafloor, where gold can accumulate in higher concentrations, it's still not an easy task to extract. The gold is embedded in rocks or mixed with other sediments, requiring extensive mining operations to collect. And that's not even considering the technical challenges and environmental impacts of deep-sea mining. So while our oceans are rich in gold, it's not a resource that we'll be able to tap into anytime soon. But it's a fascinating reminder of the wealth of resources that our oceans hold, many of which are yet to be discovered. As we delve deeper into the mysteries of the ocean, let's turn our attention to a peculiar phenomenon that has puzzled scientists for decades, a unique sound known as the bloop. In 1997, researchers detected a loud, ultra-low frequency sound in the Pacific Ocean. The sound was so powerful that it was picked up by sensors nearly 3,000 miles away. The sound was dubbed the bloop, and for many years its source remained a mystery. The sound was unlike anything researchers had heard before. It was too loud to be caused by a ship or a submarine, and it didn't match the sounds made by any known marine animal. This led to wild speculations about its source, with theories ranging from giant sea monsters to underwater alien bases. However, after years of investigation, scientists were able to solve the mystery of the bloop. The sound was not caused by a giant sea creature or an alien base, but by an ice quake, a large iceberg cracking and breaking away from an Antarctic glacier. The sound of the ice quake traveled through the water, where it was picked up by the listening devices thousands of miles away. The story of the bloop is a reminder of the many mysteries that still exist in our oceans. Even with all our technology and knowledge, there are still things in the ocean that can surprise and puzzle us. As we journey further into the depths of the ocean, we arrive at a place that is as remote as it is fascinating. Point Nemo. Named after Captain Nemo, a character from Jules Verne's 20,000 Leagues Under the Sea, Point Nemo is the oceanic pole of inaccessibility. In simpler terms, it's the point in the ocean that is farthest from land. Located in the South Pacific Ocean, Point Nemo is about 1,450 nautical miles from any land. To give you a sense of just how remote it is, the closest humans to Point Nemo are often the astronauts aboard the International Space Station, which orbits the Earth from a distance of about 258 miles. This remoteness makes Point Nemo one of the least disturbed places on Earth. It's a place of profound solitude, where the vastness of the ocean can truly be felt. But despite its isolation, Point Nemo is not devoid of life. Microorganisms known as extremophiles, which thrive in extreme conditions, can be found in its waters. Point Nemo also serves as a spacecraft cemetery. Due to its remote location, space agencies around the world use it as a dumping ground for decommissioned satellites and space stations. These spacecraft, some of which carry traces of extraterrestrial material, sink to the bottom of the ocean, adding another layer of intrigue to this remote location. Our journey takes us now to the deepest point of the ocean, a place so remote and inhospitable that it has been visited by fewer people than have walked on the moon. This is the Challenger Deep, located in the Mariana Trench in the western Pacific Ocean. Named after the HMS Challenger, which conducted the first scientific survey of the trench in 1875, the Challenger Deep is about 36,000 feet deep. That's nearly 7 miles straight down. To put that into perspective, if you were to place Mount Everest at the bottom of the Challenger Deep, its peak would still be over a mile underwater. The pressure at the bottom of the Challenger Deep is over 1,000 times greater than at sea level, and the temperature is just above freezing. Despite these extreme conditions, life has found a way to thrive. scientists have discovered a variety of organisms that call the Challenger Deep home, including single-celled amoebas known as foraminifera, and a species of snailfish that is currently the deepest living fish ever discovered. Exploring the Challenger Deep is a formidable challenge. The immense pressure, low temperatures, and lack of light make it a difficult and dangerous environment to navigate. Yet these challenges have not deterred us from exploring this final frontier on Earth. From the bathyscaphe Trieste's first manned descent in 1960 to more recent expeditions using autonomous underwater vehicles, our quest to explore and understand the deepest part of our oceans continues. The Challenger Deep is a testament to the extremes that life on Earth can endure, and a reminder of how much we still have to learn about our planet. As we delve deeper into the mysteries of the ocean, we encounter life forms that have adapted to survive in some of the most extreme conditions on Earth. These extremophiles, as they are known, challenge our understanding of the limits of life and hint at the possibility of life beyond our planet. Take, for instance, the bacteria that thrive near hydrothermal vents on the ocean floor. In these seemingly inhospitable environments, where the water is superheated and the pressure is immense, these microorganisms not only survive but thrive. They have evolved to use the chemicals spewing from the vents, such as sulfur and methane, to generate energy in a process known as chemosynthesis. Then there are the organisms that inhabit the Challenger Deep, the deepest part of the Mariana Trench. Here, in the pitch-black depths, under pressures 1,000 times greater than at sea level, life has found a way. From single-celled amoebas to the Mariana snailfish, these creatures have adapted to survive in an environment that would be lethal to most other forms of life. These extremophiles are of great interest to scientists, not just for what they can teach us about life on Earth, but for what they might reveal about the possibility of life on other planets. If life can survive in the extreme conditions of the deep sea, could it also exist in the icy oceans of Jupiter's moon Europa, or beneath the surface of Mars? As we continue our journey through the depths of the ocean, it's important to acknowledge the tools and technologies that make our exploration possible. These devices, designed to withstand the extreme conditions of the deep sea, allow us to venture where humans cannot go, revealing the mysteries of the ocean to us. One such tool is the deep sea submersible. These vehicles, which can be manned or unmanned, are designed to withstand the immense pressure of the deep sea. They are equipped with strong lights to illuminate the dark depths and cameras to capture images and videos. The bathyscaphe Trieste, which reached the bottom of the Challenger Deep in 1960, and the Deep Sea Challenger, which made the same journey in 2012, are examples of manned submersibles. Then there are the remotely operated vehicles, ROVs, which are controlled from a ship on the surface. ROVs can stay underwater for much longer than manned submersibles and are often used for detailed scientific research and exploration. They are equipped with robotic arms to collect samples and high-definition cameras to document their findings. Autonomous underwater vehicles, AUVs, like the Nereus, are another important tool for deep-sea exploration. These vehicles can operate without a tether to the surface, allowing them to explore areas that are difficult to reach with other methods. They use advanced navigation systems to move through the water and can be equipped with a variety of scientific instruments to collect data. These tools, along with advancements in sonar mapping and satellite technology, have revolutionized our understanding of the ocean. They have allowed us to explore deeper and with more precision than ever before, revealing a world that was once completely hidden from view. As we draw our journey to a close, we are left with a sense of awe and wonder at the vastness and complexity of our oceans. We've journeyed from the sunlit surface to the darkest depths, encountering along the way a world teeming with life and filled with mysteries yet to be solved. We've learned about the immense pressures and low temperatures that characterize the deep sea and the remarkable creatures that have adapted to survive in these extreme conditions. We've discovered underwater lakes and rivers, the world's biggest waterfall and the longest mountain chain, all hidden beneath the waves. We've marveled at the diversity of marine life, from the smallest plankton to the largest whale, and the crucial role they play in our planet's ecosystem. We've also learned about the challenges we face in exploring this final frontier on Earth. The deep sea is a harsh and unforgiving environment, and it takes a great deal of ingenuity and courage to venture into its depths. But as we've seen, the rewards are well worth the effort. Each new discovery brings us closer to understanding our planet and our place in it. As we conclude this journey, let's remember that our exploration of the ocean is far from over. There are still many mysteries to unravel, many species to discover, and many challenges to overcome. The ocean, with its vastness and depth, reminds us of the infinite possibilities that await us. It invites us to keep exploring, to keep learning, and to keep marveling at the wonders of our blue planet. Thank you for joining us on this journey. Until next time, keep exploring, keep questioning, and keep marveling at the wonders of our world.
Now, the Mariana Trench is the deepest and probably the most enigmatic place on Earth, whatever that means. Bizarre creatures, such as deep-sea anglerfish, frilled and goblin sharks, barrel-eyed fish, hatchet fish, live in a crescent-shaped trench in the western Pacific. Just 3 people have ever descended down the Challenger Deep in the southern end of the Mariana Trench. There, at a depth of almost 11,000 feet, vents are bubbling up carbon dioxide and liquid sulfur. Mud volcanoes erupt under the pressure 1,000 times greater than at the surface. And so, it's no place I want to go. So bye!
Get back in there.
Alright, since you clicked, yeah, you're about to visit places no less mysterious and creepy than the Mariana Trench. Your first stop is Mexico, the Yucatan Peninsula to be precise. See those bottomless sinkholes filled with crystal clear water? It's fresh water that overlies salt water seeping from the sea. The sinkholes are called cenotes. The Mayans believe these natural wells were the gateways to the underworld. Thousands of cenotes, created by collapsed limestone bedrock, form one of the world's longest underwater cave systems. You can easily get lost in this tangled, mysterious network. Now it's time to visit the Caribbean. There, you'll get to a depth of almost 8,000 feet to see the Van Dam vent field. The hydrothermal vents fire out streams of muddy, scalding water with a temperature reaching 400 degrees Fahrenheit. That's almost enough to bake a pizza. These mounds are made of talc, a substance you can find in baby powder. The Van Dam vent field is an oasis for odd species. One of those is kind of a creepy shrimp without eyes. Instead, they're equipped with patches of light-sensitive cells on their backs. Now, you don't have to travel far away. The next enigma on your list is also in the Caribbean. Just off the coast of Belize, there is a giant sinkhole. It's also blue. Yep, that's the Great Blue Hole. The thing is about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave until rising waters filled it, making it collapse in on itself. The deeper you descend into the Great Hole's crystalline waters, the darker it becomes. You see tons of stalactite-filled caves, but don't even try to enter them unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you notice the water shimmer. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. Time to get out of there. Who knows what you might come across in the murky depths? Your next destination is off the Pacific Northwest coast. Almost 500 streams of methane bubbles were discovered there several years ago. Because of the bubbles, the vents got the name champagne seeps, which sounds better than the fart spas. Scientists are still puzzling over this phenomenon. Where does the methane come from? Underwater cows? Why is its temperature warmer than that of the surrounding ocean? And most importantly, what would happen if you managed to light a match somewhere near a large bubble? Methane is a highly flammable gas, and setting a methane bubble on fire, well, you get the picture. And now you're off to Iceland. The plan is to dive into Silfra, a fissure filled with pure glacier water. This 206-foot deep crack is the only underwater place on the planet where you can touch 2 continents at once. The deeper you go, the darker it becomes. The rocky landscape looks otherworldly. Divers who dare to visit this incredible place risk having their gear frozen, getting hypothermia, or not surviving whatsoever. After all, the water temperature in Silfra Fissure is about 35 degrees Fahrenheit year-round. Your next destination is Scotland. Okay, cue the bagpipes. If you dive in the Gulf of Corryvreckan, a narrow strait between two islands, you'll see massive underwater rocks and deep holes. They create the third largest permanent whirlpool on the planet, the Corryvreckan Maelstrom. The water moves through the strait at breakneck speed. It hits the underwater rocks, and the place looks like a pot with boiling water. The waves created in the process sometimes reach a height of 15 feet, and you can still hear the roaring whirlpool from 10 miles away. It's believed the Corryvreckan Maelstrom has swallowed dozens of sailors over the centuries. They were caught unaware by the ferocity of this natural phenomenon and pulled underwater in the blink of an eye. Okay, enough bagpipes. Your adventures are getting more and more extreme. You're heading for Antarctica. There, in the Southern Ocean, you'll find the Ross Sea Ice Shelf. Say that 5 times real fast. Later, not now. It's roughly the size of Spain, with the ocean underneath containing as much water as the North Sea. Once, scientists drilled all the way down through this enormous chunk of ice. Imagine their astonishment when they found life in those extreme conditions. The researchers came across dozens of mysterious species not known before. The most unnerving were upside-down swimming fish and overturned sea anemones hanging in the frigid waters. Hopefully, bizarre places with a notorious reputation don't frighten you. Well, too bad, because you're about to visit the Bermuda Triangle. It's an area between Bermuda, Florida, and Puerto Rico where planes and ships seem to vanish in thin air. For the first time, this place attracted a lot of attention in 1945. That's when 5 U.S. Navy planes disappeared during training. Before radio contact was lost, the flight leader said, "We're entering white water. Nothing seems right." After that, the planes with 14 men flying them disappeared. Even scarier, a rescue plane with 13 people on board never came back as well. Some people believe the mythical city of Atlantis lies at the bottom of the triangle. They claim its inhabitants use extraterrestrial technologies to sink ships and crash airplanes. Others blame rare and unexplored natural phenomenon, for example, magnetic anomalies, or massive pockets of flammable methane gas. There we go again. Then, if a bolt of lightning ignited a giant methane bubble near a ship or a plane, this could probably make it sink without a trace, except the smell. But methane is found everywhere all over the world, and it never behaves this way. Some experts aren't sure there's a mystery to explain whatsoever. Lots of busy routes pass through this area. No wonder more ships and planes sink there than anywhere else. Now, prepare some warm clothes. You're heading for the north again. Your destination is Cape Desolation in Greenland. Nice place. In 2012, Canadian researchers were sampling the water in that area, and their equipment came back to the surface with pieces of coral attached to it. That's how a cold water coral reef was stumbled across. These unique pinkish corals can easily go without sunlight and live in strong currents 3,000 feet below the surface. Another unique spot you can't miss lies between Greenland and Siberia. The Geological Ridge is the deepest and most remote portion of the global mid-ocean ridge system. In some places, it reaches the depth of more than 3 miles. It's only natural the darkest corners of this underwater world remain unexplored. Fascinating chemical reactions happening at the bottom of the ridge produce hot fluids rich in minerals. They spew, like freshmen at a rush party, from seafloor vents. And since these vents are isolated from the rest of the ocean, they're hot spots for bizarre creatures found nowhere else in the world. Your next stop is just off the coast of Cuba. Circular columns, paved floors, symmetrical stone structures. That's what the Cuban underwater city looks like. What happened there? Why was a large city abandoned at a depth of more than 2,000 feet? Lots of people believe those are the ruins of a long-forgotten civilization. But scientists have their doubts. They claim the lost city is nothing but a natural phenomenon that appeared about 5 million years ago. The disc and donut structures often appear around the areas of the seafloor where natural gases break free. Again with the gases. When you come to visit the Sargasso Sea in the middle of the North Atlantic Ocean, you won't find its shores. Instead, it's surrounded by powerful ocean currents. These are the same currents that turn the sea into a gigantic convention for dense brown seaweed. In the 19th century, a French ship was discovered in the Sargasso Sea. Its sails were set, but not a single crew member was on board. This mysterious disappearance made people believe the seaweed was carnivorous. The Sargasso Sea is indeed a weird place. It's always eerily calm and unnaturally warm, even though it's surrounded by the churning, freezing waters of the Atlantic Ocean. Could one of these bizarre places become a home to the largest marine predator ever, the megalodon? The giant shark's teeth, some larger than an adult man's hand, have been found pretty much all over the world. But since these creatures preferred warm, shallow waters, they lived along the coastlines of all continents except Antarctica. In other words, it'd be a waste of time to search for the giant predator in the depths of the Mariana Trench, in Greenland, or in Mexican cenotes. But then, could it choose the waters of the Caribbean to hide from the hustle and bustle of the modern world? Don't get your hopes up. There's been no proof the megalodon does exist these days. It wasn't a shy, elusive animal, and still, no one has seen this shark lurking around recently. Not even near the fart spas.